Hello everyone. Welcome in a lecture series for the subject Engineering Mechanics. I'm Assistant Professor Radhika Kapate from Vishwabharati Academy's College of Engineering and Engineering Ahmednagar. In previous lecture, we seen the fundamental concepts and basics for the which is required for the engineering mechanics. Now, in this lecture, we have to see the details, and we are learning from Unit One, that is triangle law, polygon law, parallelogram law. So many concepts in from first unit. Okay, so here we starting our lecture on first unit of engineering mechanics. I hope screen is visible. So in this lecture, we are starting that is system of forces. So in a system of forces, we seen in a previous lectures that is the so many systems of forces like coplanar, non-coplanar, collinear, non-collinear, parallel, non-parallel, and concurrent and non-concurrent. Okay, so we seen their examples and how they act in a coplanar and non-coplanar plane. Okay. Now we have to see that is composition of forces. So what is the meaning of composition forces? That is forces added to obtain a single force which produces the same effect as the original system of forces. The single force is known as a resultant force, and the process of finding the resultant force is called composition of forces. Then the composition of forces, there are two methods of finding resultant. One is analytical and second is graphical method. In analytical method, there are parallelogram law and methods of resolution. Now you can see in the diagram numericals on parallelogram. Before that, I want to say statement of the parallelogram law. So, what is the statement of parallelogram is if two coplanar concurrent forces are acting simultaneously at a point and point which are represented in magnitude and direction by the two adjacent sides of parallelogram, then their resultant may be represented in magnitude and direction by the diagonal of parallelogram and which is passes through their point of intersection. Now, so here type 1, that is the problem on composition of forces by parallelogram and triangle law. So in parallelogram, you can see here the forces from point O is Q, and from point O to B is Q, and from O to A, that is force P, and the resultant that is represented in diagonal, okay, that is R. So how to calculate resultant is R is equal to under root P square plus Q square plus 2PQ cos of theta. And how to find out the angle which is made with the resultant or diagonal, that is alpha is equal to tan inverse in bracket q sine theta divided by p plus cos of theta. So these two terms are important in the solution of the law using law of parallelogram. Okay. So in next, that is the triangle law. What is mean by triangle law? If two coplanar concurrent forces are acting simultaneously at a point which is which are represented in magnitude and direction by the two sides of a triangle taken in order, then the resultant of these two forces is represented in magnitude and direction by the third side of the triangle in opposite order. Now you can see in this diagram from point O, the force O from point O to A, that is force P, and from point O to B, that is resultant, and from point A to P, that is the force Q. So what is the equation from this triangle law? R is divided by sine beta is equal to P divided by sine alpha is equal to Q divided by sine theta. These are the respective angles. Okay. Now, what is the R? That is resultant of force P and Q. Theta is the angle between P and R. Here in the diagram. Next, angle between P and Q is beta, and alpha is the angle between Q and R. So, there is first numerical, that is find the resultant of following forces using or method by parallelogram law. Okay, so there is two forces, that is 3 Newton and 4 Newton, and here by parallelogram law, as we know, the equation, that is R is equal to P square plus Q square under root P square plus Q square plus 2PQ cos of theta. Using this and putting all the values for the P is 4, Q is 3. So 4 square plus 3 square plus 2 into PQ, that is 3 into 4 into cos of 90 degree, because angle is 90 degree. So from the using calci, you can calculate this and you will get the resultant, that is 5 Newton. Now we have to calculate the angle of this resultant. So using the equation for the parallelogram, that is for the finding angle. So here is angle tan alpha is equal to P into sine of theta divided by P plus Q sine of cos of theta. So using this, putting the values, that is 3 sine 90 degree plus 4 plus 3 cos of 90 degree, and whatever the answer is there, you have to convert it, that is tan inverse into what the answer is in bracket. You will get the value of alpha. Now, the second numerical for using by triangle law. So you can see here there is a diagram. So using triangle law, R is equal to under root P square plus Q square minus 2PQ cos of 90. You get this value of resultant, that is 5 Newton. Now by using sine rule, we have to find out R divided by, we have to find out angle, and that is R divided by sine of 90 degree is equal to 3 of sine of alpha. So sine of alpha is equal to 3 by 5, and we have to calculate the single value, that is alpha. So you have to do sine inverse into whatever the answer coming from 3 by 5. You will get the value of alpha, that is 36.87. Now next, you can see here the different types of numerical for the exercise. Now, resolution of forces, definitions and problems. What is mean by resolution? So, the way of representing a single force into number of forces without changing the effect of forces on the body is called as resolution of forces. So, for first, there is a first example. As shown, two forces act at an angle of 120 degrees. Here you can see in the diagram. The bigger force is of 40 Newton and the resultant is perpendicular to the smaller one. Find the smaller force. You have to find out the smaller force, and bigger force is 40 Newton is given, and angle is given, that is 120 degree. So referring figure, given angle between the force A angle AOC is 120 degree, and bigger force you can call it F1, that is 40 Newton, and angle between the resultant and F2, that is angle BOC, is equal to 90 degree. So let F2 is a smaller force in a Newton. So from the geometry of figure, we find that angle AOB alpha is equal to 120 minus 90 is 30 degree. So we know tan alpha is equal to F2 sin theta divided by F1 plus F2 cos of theta. So putting all the values, we'll get the value of F2, and that is tan theta, that is the alpha's value, is equal to F2 as it is, because we have to find out the smaller force. So F2 sine of 120 divided by 40, that is bigger force, plus F2 as it is, because we have to find out value of F2, and cos of 120. So from this we get the value of F2. Now, in a second example, you can see, resolve the 100 Newton force acting a 30 degree to horizontal into two components, one along horizontal and other along 120 to horizontal. So, using two methods, that is, first one is by parallelogram law method and second is by triangle law method. So, using first, there is resultant is given. So putting this in, R is equal to under root F1 square plus F2 square plus 2 PQ cos of theta equation. We have the value of R, putting here 100 is equal to, and we have to calculate the forces. So under root F1 square plus F2 square plus 2 F1 F2 cos of whatever the angle is, that is 120 degree. Now from this we have to calculate F1 F2. So the equation is formed like 10,000 is equal to F1 square plus F2 square minus F1 plus F1 into F2, that is equation 1. Now tan theta, that is given 30 degree for angle of resultant. So tan 30 is equal to F2 sine 120 divided by F1 plus F2 cos of 120. From this, we get the value